Given a function y equals to square root 3x squared plus 2x, write y as composition of functions f and g. Which means y equals to f of g of x. Where g of x is 3x squared plus 2x and f of x is equal to root x. The function g is differentiable at x and f is differentiable at g of x. Then dy dx is equal to the derivative of the outside function times the derivative of the inside function. Therefore, dy dx equals to 1 over 2 root 3x squared plus 2x times the derivative of the inside function, which is 6x plus 2. Taking common factor of 2 in the numerator, we obtain 2 times 3x plus 1 divided by the denominator. Cancelling out 2, we obtain dy dx equals to 3x plus 1 divided by root 3x squared plus 2x. Given y equals to root 3x minus 5 plus root 4 minus 3x, using chain rule on each of the terms, we have dy dx equals to the derivative of the outside function, which is 1 over 2 root 3x minus 5 times the derivative of the inside function, which is the derivative of 3x minus 5, which is equal to 3, plus the derivative of the outside function, which is 1 over 2 root 4 minus 3x times the derivative of the inside function 4 minus 3x, which is negative 3. Rearranging, we obtain dy dx equals to 3 divided by 2 root 3x minus 5 minus 3 divided by 2 times 4 minus 3x. Taking 3 over 2 as a common factor and rearranging, we obtain dy dx equals to 3 over 2 times 1 over root 3x minus 5 minus 1 over 2 root 4 minus 3x. Given y equals to square root 1 plus x squared divided by 1 minus x squared. Write y as composition of two functions. Let f of x equals to root x, the outside function, and g of x equals to 1 plus x squared divided by 1 minus x squared, the inside function, so that f of g of x equals 1 plus x squared divided by 1 minus x squared under root, and dy dx equals to the derivative of the outside function times the derivative of the inside function. Since y can be written as y equals to root g of x, dy dx is equal to 1 over 2 root g of x times the derivative of the inside function g of x. Let's label this as a and find the derivative of the inside function g of x, which is equal to the derivative of 1 plus x squared divided by 1 minus x squared. Apply the quotient rule. We have the derivative of the numerator, which is 2x, times the denominator, 1 minus x squared, minus the numerator, 1 plus x squared, times the derivative of the denominator, which is negative 2x, divided by 1 minus x squared whole squared. Multiplying the terms in the numerator, we obtain 2x times 1, 2x, minus 2x times x squared, 2x cubed, plus 2x plus 2x cubed, divided by 1 minus x squared whole squared. This gives us, cancelling out, negative 2x cubed and positive 2x cubed, 4x divided by 1 minus x squared whole squared. Therefore, dy dx is equal to 1 over 2 root g of x times g prime of x. Since we know the g prime of x, we'll substitute the value of g prime of x in the original equation labeled a, which gives dy dx equals to 1 over 2 root 1 plus x squared divided by 1 minus x squared times the derivative of g of x, which is 4x divided by 1 minus x squared squared. Rewriting the first term as root 1 minus x squared divided by 2 times root 1 plus x squared multiplied by 4x divided by 1 minus x squared whole squared. Cancelling out the common factor 2 and multiplying the numerator and denominator with square root 1 minus x squared, we obtain root 1 minus x squared times root 1 minus x squared divided by root 1 plus x squared times root 1 minus x squared times 2x divided by 1 minus x squared whole squared. The numerator here becomes 1 minus x squared divided by the denominator, which is root 1 minus x to the 4 times 2x divided by 1 minus x squared whole squared. Now cancelling out 1 minus x squared with 1 minus x squared in the denominator, we obtain dy dx equals to 2x divided by root 1 minus x to the 4 times 1 minus x squared.